Well, thank you everyone for joining us. Today we're talking about how we're destined for bioretention, a little bit of wordplay on how Tacoma is the city of destiny, and it seems like all of our stormwater solutions end up sort of pointing towards bioretention. So about us, I'm Scott Treber. I'm a stormwater engineer for Tacoma, and my co-host Shauna Hansen, she's also a stormwater engineer and is our stormwater permit and program coordinator. We also have some special guests that are I guess, in-house experts on some of these facilities. We have Olivia Matheson, who's an engineer and project manager, Kevin Brennan, who's our source control kind of expert, and then Eric Tate, who's also a source control expert, but he brings a maintenance background with him as well. So some things I'm hoping to talk about today is just green infrastructure in general, bioretention and how it can be a versatile tool, and then also how it's important to stay flexible in our planning processes and design processes. And lastly, how a one size fits all approach typically isn't the best solution. So what is GSI? Um, GSI or green stormwater infrastructure, or some people, depending on the region, just call it green infrastructure, is a pretty large umbrella term. And it's not specific to just stormwater, although we'll be touching about that a lot today. There are also a lot of roadway or other site development components that can be influenced by green infrastructure. And I like to think of it as just kind of a new lens in how we look at our infrastructure and what we're building for our communities that has different focuses. A lot of the focus is on using these different strategies to build a community or environment where people can cohabitate with the natural environment as if we weren't there. Some kind of key aspects to that is it's oftentimes focused on tree canopy, or adding plants, or kind of reducing the total amount of hard surfaces that we're putting in with our projects. Another kind of focus on green infrastructure is a lot of co-benefits. I think stormwater is kind of unique in that it affects everybody. It affects humans. It affects our waterways, the Puget Sound, and so we try and look at everything that can possibly benefit from these styles of projects or that lens of projects. So this list of co-benefits here is taken straight from the GSI Impact Hub calculator. So we're looking at things like the avoided infrastructure costs, and that could mean a variety of things. But my favorite example is like a typically maybe depressed, when I say depressed economically, community that maybe doesn't have formal stormwater conveyance system, or they have bad roads. And so instead of having to pay money to do all new hard roads and have to put in uh, structural or pipe conveyance systems, we could go through and maybe put in pervious roads. So they're getting a new road and they're getting stormwater management all in one instead of having to do both things, the road and the conveyance system. There's also factors like heat stress. So this map on the right is a heat map of Tacoma, and this most blue part up in the north end versus the red parts of Tacoma, that represents an 8-degree change in average air temperatures. And so in areas like this downtown portion, right next to the foss, or a lot of the red that's kind of in what we would call the lower Puyallup area that's really red, we're focusing on projects that put in a lot of street trees. So we're trying to increase the tree canopy that helps slow down stormwater and also provides shade and lowers the overall temperature. And there's also, when you're lowering the overall air temperature, you're going to improve things like recreation. It's hard to think of recreation in a city, but a lot of people are walking to and from, like around in the businesses or from their homes to their work. And so a big factor in heat stress is that people are able to be mobile in their communities without being burdened by the environment. And all of these kinds of concepts are talked a lot or are talked about a lot in like the GSI exchange that I've linked here. It's a great cohort that's focused on, or actually an accelerator program that's focused on bringing people up to speed on a lot of these concepts and helping cities and communities build programs of how to implement a lot of these philosophies into their infrastructure and projects. There's also this APWA Biophilic meeting. If you're kind of interested in maybe the co-benefits of how people's mood or their sense of community improves with adding greenery or trees to their infrastructure, that would be a great committee to be a part of and more. Um, another concept is kind of leaning on the biophilic portion, and something that Tacoma likes to coin quite often is like the greenscape enhancement of a project. So whenever we have a normal corridor project, we like to try and add things to it. So whenever we're doing a project and we have to have stormwater, a lot of times the focus is on just trying to do the bare minimum, what is required by that the development and redevelopment requirements. And oftentimes that means adding things like storm filter cartridges or just giant wet ponds if you're in a more rural area. And I like to try and think of these stormwater facilities as an opportunity to add something else to these projects. So when we're looking at what we can add, things like adding plants and trees to the project, it's more than just greenery. It's more than just stormwater treatment. It improves that overall aesthetic. And as a public servant, I want the people that I serve to feel like my work is addressing their needs and I'm providing something they need. So if I am doing a project in a neighborhood and I have to put a vault right in somebody's front yard or their planter strip, that's something they have to deal with for, I don't know, I guess the rest of the time that they want to live there. But if I can add something like, this bioretention swale that we see in the picture here, that's something that is aesthetic, it's cool, people can see kind of stormwater in action and how we're treating it. And we want to have community buy-in. So if they want these components added in their project, they're more likely to care for it or be proud of it. There's also measurable landscape performance benefits. So things like the Landscape Architecture Foundation do a lot of research involved with how the plants that we choose and how we design our landscaping can reduce things like costs in irrigation or just long-term maintenance costs. So it's not just about putting plants in the ground, it's about putting the correct plants in the ground. So all that kind of community focus with green infrastructure and maybe adapting and selecting certain components and making additions to projects to a project that makes it kind of holistic and customized to the community and their needs is one of the reasons, or one of the many reasons why this 40th Street Green Roads project that we're going to talk about here, I think is really unique and special. So this is one of the sites that we're going to be touring on Wednesday. It's a Green Road Silver project. It has kind of some interesting components like a road diet, very community focused. And it's kind of interesting the story that Olivia is going to tell us a little bit about how it grew from something that was maybe really small into a greater project. So Olivia, if you could, like I said, tell us a little bit about this project, what it came from, and what it grew into.
Thanks, Scott. Can you hear me?
Yep.
Okay, great. This is a new headset I'm trying out. First of all, my name is Olivia Matheson with an Environmental Services Engineering, Science and Engineering Division. I'm currently a senior engineer, but at the time of this design and construction of this East 40th Street green stormwater infrastructure project. I was an associate engineer working under another stormwater professional, well known in this group, Jessica Knickerbocker. Um, but at the time of the design of this project, uh, the genesis of the project began with the concerned citizens call to the city of Tacoma regarding flooding within their backyard. And at first, the citizen requested to have a, a, a rain garden constructed. But after further evaluation by the design team, we looked beyond that and looked to partnering with others within the environmental services division, and also with Tacoma Water, Tacoma Power, and also City of Tacoma Public Works, and also with Department of Ecology. And we landed on the lower life cycle. We decided green stormwater infrastructure was the most cost-effective solution for this project, because the traditional design methods was estimated at nearly twice the cost of insulation. So some of so because the localized flooding happened at within the East Tacoma neighborhood, East Tacoma particular site location looked more like a fishbowl. So there were many side streets that we looked into, also treating stormwater on site. And that also included additional BMPs that we started looking into implementing for the project site as well. And also because the road was also had amazingly wide right of ways, varying between 80 to 100 feet wide. The design team took advantage of these wide right of ways by installing some biofiltration swells for basic treatment of runoff and runoff coming from the side roads in the greater neighborhood, and also treating the water quality and quantity improvements were also applied to the basin by installing permeable pavement areas to infiltrate about 20 acres. Also, the overall project treated about 30 acres with the biofiltration swells and the ballasted sidewalks and pervious pavement, and also the installation of emergency overflow ponds as well for upgrades to future design for future stormwater increases project site. So I think that was particularly the genesis of the project and how we came to design some of the BMPs for the project sites, and the incorporation of the input from the residents, the businesses, the churches, and also the sorry, I'm getting pop-ups. And also some of the neighboring folks in the area where they had some concerns addressing safety for school students, and also getting mobility from one site, from opposite ends of the project site, by completing a continuous sidewalk for students and separation from the roadway with the street buffer, and installation of the biofiltration swells, and also street trees.
So there's a before picture of 40th Street, right, Olivia? And kind of the conditions that you were working with when the community was when you were reaching out to the community at first. Could you talk a little bit more about, and then maybe Scott, we could show some of the start of the after photos. But could you talk a little bit more, Olivia, about what the community engagement process was like, and you were working particularly with the local school there in the neighborhood?
Sure. The local church, the local area the street was fronted by a couple churches, several businesses, Blix Elementary School, private development, and residences along the routes. And there was a concern with safety for the students. Uh, in the photo, you see the gravel parking pull-in area where parents would drop off their students and pick up students at the beginning and at the end of every school day. So the school impressed upon us they would prefer a designated parking pull-in, pull-out area for their parents, for the parents and for the school buses. They also requested a continuous sidewalk for their students to walk on as well. So we reached out to several technical advisory groups within the city, within the community, with the BP tag, which was a bicycle pedestrian technical advisory group within the city, and came up with several solutions to address some of those concerns, such as a raised cross path right near the crest of the roadway, and also to construct a park and pull-in area and to construct the continuous shared use path throughout from McKinley to Portland Avenue.
And about how far is that? Is that like a mile or about a half mile?
Total, it was about 10 blocks from
10 blocks. Okay.
Yes.
And then is this kind of before picture? We didn't have a ton, but is this pretty representative of what that whole corridor looked like? Open shoulders and maybe ditches, but no existing sidewalks, correct?
There, what we would consider non-contiguous sidewalk. There were some
Gotcha.
private improvements that constructed some sidewalk sections. And then towards Portland, there were also pieces of sidewalk, but none that completely connected to each other. And in this area, you see a 34-foot wide traditional asphalt roadway, landscaped areas and roadsides, but not too much of any sort of, there wasn't any presence of any stormwater features at all, for perhaps just a traditional catch basin and conveyance system.
Okay. I think this is kind of a situation that maybe a lot of counties will see in more undeveloped areas or quickly urbanizing areas. Is they'll have a roadway, big shoulders, and not really any other features. So it's cool that we're able to maybe add, well, take this road section and maybe turn it into this, which is 40th as we see it now.
Correct. In this particular stretch of road width, you see it's 80-foot wide, and we reduced the roadway width from 34 to about 10-foot lanes one way each direction, with 1-foot flat curbs, and then the 14 to 15-foot wide swale with the 16-foot wide concrete shared use path, forested, ballasted sidewalk area. So that's how we were able to conceptually design this area within this width. And as you go travel towards McKinley, there's 100-foot wide right of way. And in that case, we were able to meander the concrete shared use path to the other side of the roadway towards Pipeline Road, which in itself was a future upcoming project, which allowed for the connectivity of the future bike trail system, as stated in the city transportation master plan. So there were a lot of ideas in play as far as the upcoming transportation master plan as well for the city that we had to incorporate into this design project, and the non-mobility and the multimodal transportation design.
And I've dropped a summary of the project in the chat, but could you talk a little bit more about the Green Road certification on this project and kind of the elements, some of the elements that played into getting that certification?
Sure. Green Roads International is what it's called today, but at the time it was called Green Roads Foundation. It's a nonprofit organization that uses a rating system developed to measure and manage the sustainability of transportation projects. So it's primarily a tool to encourage the reduction of environmental impact and resource use of transportation projects. And in this case, the city was able to complete the project requirements, from which there were 12, and receive about 51 points total for the silver certification of this project. The majority of the points in the rating system were acquired through the environment and water criteria for the project as part of the project rating system. And because the project itself was able to incorporate to treat about 30 total acres of the project with the use of the ballasted sidewalk, the permeable pavement, uh, the biofiltration swells, and the use of landscape to bring the existing area back to the natural infiltration that existed before. We were able to we were certified as silver certification status.
Really quick,
Okay.
Olivia.
Yeah.
I know this is done by or kind of championed by environmental services, but there's a lot of components going on here. Um, I know this is a partnership project. Could you kind of tell us like how it kind of evolved from that? You mentioned that property owner had a rain garden request. Like, how did it evolve from that garden request up into this big project? Did we try
That's
to install a rain garden? It didn't work, or did we just kind of look at the area in general and say, actually, there's a lot bigger need than just this one property owner?
initially the site was evaluated for just the area at the bottom of the fishbowl, which was at this residence address, which encompassed about six blocks. But because of the need to also upgrade the city's stormwater conveyance system, and also to improve the water mains, and also to upgrade the city's street lights, and also the sidewalks within the area. We were able to work with a lot of our partners within Tacoma Water, Tacoma Power, and uh, Public Works Engineering, who provided additional $75,000 per block to uh, to fund the roads outside of the plan for initially designed for permeable areas. And as you can see, initially the project itself was 6 blocks, but it grew to 10 blocks from McKinley to Portland, and then an additional 2 blocks north in East 38th in East I Street, in East House Street to East 38th Street to as well.
So to wrap up this section, we do have a few questions in the chat about the permeable pavement aspects of the project. So I think one thing to start with, could you clarify, Olivia, about the sidewalk or the shared use path? Now that is permeable, but it's not permeable pavement, right? You mentioned it's ballasted sidewalk. So could you describe how ballasted sidewalk works in this project?
Sure. As you know, traditional sidewalk itself allows for storm to run off and into the adjacent areas. But in this case, we were able to store more rainwater and have it infiltrate back underneath the concrete shared use path by the use of the porous rock as a shoulders alongside the poured areas of concrete. So it is actually used as a storage area for stormwater runoff and to infiltrate back naturally into the ground.
And by
So what
so
I'm
oh, yeah.
seeing is there's a, I mean, I see almost looks like a 1 foot gravel buffer, and you're saying that's not what's going on here. Is that something else? So I guess
You're referring to the 12-foot wide concrete path with the 2-foot wide crushed rock surfaces, side areas. Is that what you're asking about?
yeah. So you said it's ballasted sidewalk. So like what does that mean? Is this whatever hits the sidewalk is running off, and then it goes into that gravel strip and then infiltrates underneath the sidewalk?
Yes, that's correct.
Correct. Okay.
That's the initial function of the ballasted sidewalk. Yes.
Okay. So that's a little bit different than like your normal sidewalk in terms of the material they use. How thick is that ballasted section?
In these areas, they were planned to be about 4 inches deep, and in other areas where Tacoma water facilities existed, they were planned to be a little thicker to accommodate the load of their maintenance vehicles. So those were thickened to about 6 to 8 inches.
And so the selection of the permeable pavement on the project and also the balsa sidewalk, was that based on the soil type? Were these soils pretty good at infiltrating or?
As with a lot of the insulation or feasibility of the sites for considered for BMPs, we have to do some preliminary geotechnical design work, and most of the site investigations were found that the soils were conducive to the BMPs and infiltrated very well.
Great. Okay, and then John Cole had one other question, and Bill, I think we can send out the specifications for the ballasted sidewalk, or at least the standard drawings that we have. That would be easy enough. But we were just wondering, John Cole was wondering about the maintenance of the permeable pavement. And so I was wondering if Eric Tate could come on and talk a little bit about the ongoing inspection requirements, how those happen, and how the maintenance is going, and how we perform the maintenance.
Yeah, can you guys hear me?
Yes.
Yep.
Yeah, so my name is Eric Tate. I'm with ES and Source Control. So what we do is we have all of this pervious asphalt and concrete, kind of different areas of the city. And we actually contract, I don't know the vendors group, Scott might know, but we bring a specific sweeping machine that actually cleans the pervious pavement. So it's different than the normal sweeper. And this year we actually kind of got lucky. We actually, another prototype. So we actually had two for all the locations around the city. So it's typically takes about a month to a month and a half to clean all of the pervious, we'll call it pavement, throughout the different locations of the city. And once that occurs, what I do is we have a test. It's like a pre-wet test. I have a couple different items and I use 1 gallon to 5 gallons. It just depends if it's called percolating. If the water disappears at a certain, we have a set time limit. And so what I do is I either pass or fail all of the different locations within the city yearly. So we kind of see each year what is passing, what is failing. So
And right now, the contractor we use to do that is we're borrowing Pierce County's contractor. Is that right? How do we do that?
so how I understand it is our contractor came from Alaska, I
Oh,
believe is where he came from.
yeah.
I know we've had discussions where potentially what's going to happen in the future, if budget is maybe we'll buy a machine and then we're going to split the cost with the different municipalities around our area. So maybe we don't need to rent one from like a different state. Maybe we have one and then we rent it out. But then there's a lot of uh, differing, who pays for it, who does the maintenance, how does that all work? So there's a lot of like ideas on kind of how we're going to do this in the future. But one of the things that is unfortunate, it's really expensive, the maintenance to get these things cleaned. So that's something too that maybe we need to have more discussions because it is a very costly expense to have this done. So like this year we had the two machines, and then how it works is we have a vector from sewer transmission on site as well to give them water, and then they need to go and clean their machines every day. So we have a vector, so we have an operator and his assistant with them all day. So there's pretty much 4 people all day for a month and a half on this project. So, and I don't know if it took a month and a half or maybe 2 months. I don't know the exact time frame, but they were done by August this year. So it's definitely, unfortunately, just very costly for the maintenance every year.
And I posted a inspection checklist we have for the water test that Eric referenced, and then the water test standard that we use in the chat if anybody wants a reference.
Thanks, Kevin.
Well, and real quick, Eric, I guess maybe a candid opinion, but how do you think these previous facilities are doing? Is it all sunshine and roses, or maybe there's some room for improvement?
I think there's always room for improvement. It seems the locations that get the heaviest traffic are the locations that aren't going to pass or need that really like almost like more maintenance. But it seems like the concrete pervious does better, in my opinion, from what I've noticed. I've only done it for a year now, but it seems to always like percolate, you know, it always infiltrates that water pretty good. So where the asphalt, it seems like some of like if there's big tree covers or if like people park on a specific section, you know, all the time, it seems like those are the ones that are not doing as well. But once again, it's what I think of fear is with going in the future is if there's like an oil spill or if there is a big diesel spill, like what is the protocol and how are we going to clean this? Because if it soaks into the pervious, you know, asphalt, how do you remove that if it goes, you know, maybe that's like 5 feet down in there. And if you only use that sweeper machine, it's only going to go down 2 to 4 inches, I would imagine at the most, kind of going over and cleaning it. So I think
Yeah.
there's something that we have to look in the future on how we can do things maybe differently or what we need to do.
Well, awesome. Thank you very much, Eric. I think it's good to address like the needs of your maintenance people and your source control inspection people. They're the ones that are kind of like owning these facilities after they get installed. And so I feel like a lot of times maybe planners and engineers get carried away with cool ideas and cool projects and get things built, but then we don't have the after effect kind of taken care of. And I think that's maybe a struggle Tacoma has in general on some of these facilities is we had some good ideas, got cool projects installed, and now we're still kind of working out the kinks and bugs on how to maintain these projects. And maybe in figuring that out, maybe we'll do things differently in the future. All right, so I want to move along here to back to bioretention. So kind of in the realm of I guess how 40th Street was a very versatile and kind of dynamic project. I think it was really good at addressing the community needs and being kind of customized over time to fit that site specifically. And with that aspect, I think bioretention is a really cool BMP or just a technique that has a lot of flexibility. So I know it's really popular with some of the stormwater scientists or the people that are like looking at like pollutant toxicity. It's really well studied. So there's a lot of scientific support that bioretention does what it says it's doing. And it was kind of developed around trying to replicate what nature does to clean our stormwater naturally. Super flexible in how it's laid out, where you can put it. It's typically really affordable since it's a very basic form. It's just putting dirt in the ground. And for those of you that are concerned about coho die-off and 6 ppdq, this is still the preferred form of stormwater treatment for 6 ppdq. So I think a lot of folks on here know the essential functions of bioretention, but there's a couple key things that I want to point out as we're going through maybe some varieties of bioretention. And the key thing here is your 18 inches of the soil media. You're gonna have a ponding area on top, and then you're either going to be infiltrating naturally into the soils, or maybe you put an under drain into the system to still get your stormwater to filter through the media and then pipe it somewhere else. This photo is example from, yeah, this is from Tacoma, but some limitations on it. It does take up space. So if you're purely concerned about performance, and by performance, I mean a volume of water treated given a certain size of BMP, bioretention does pretty poor in that manner. You need a large surface area to treat a large amount of water. Nutrient transport can be a concern too. The bioretention media, or by media I mean a blend of like soils and compost. The compost amended portion can transport a lot of nutrients. So if you have a protected water body downstream that you're worried about, maybe conventional bioretention is an issue because you don't want to leach that phosphorus into the water body. Now, as a alternative, there's a newer media that was developed by ecology. It's called the High Performance Bioretention Stormwater Media. Their SAM program helped develop this, and the big problem that they were trying to solve was that phosphorus leaching issue that I mentioned. So that 18-inch media is replaced with kind of a mixture of filter sand, coconut coir, and wood ash, or they have done some studies on using the biochar or using biochar instead of the wood ash. That flow through rate through the media is in the realm of 12 inches per hour versus the regular bioretention is 4. So if you've got really high naturally infiltrating soils and you kind of just want some smaller bioretention cells, this could be an option. And there's some different configurations depending on what your goals are. But really the goal here is to use this polishing layer that goes underneath the 18-inch mix, and that polishing layer just removes phosphorus. Kind of in that realm, Bellingham developed POST, or phosphorus optimized stormwater treatment. This was kind of developed around the needs for the Lake Whatcom. They had a pretty bad nutrient problem, and so they wanted to develop a non-proprietary media that was able to do things like your basic and metals treatment and also remove phosphorus. So they did a lot of studies, developed kind of an interesting structure of media. Kind of the big bullet points there is that you get a 60 inch per hour infiltration rate, and like how the HPBSM was sand, this media is actually using an aggregate or a wash rock, then coconut coir and wood ash. And this also has a polishing bed that's made of aggregate, activated alumina, and metal filings. So their goal was to get basic metals and phosphorus, but as of right now, or when they got the approval last July, I think, July 2024, it got approved for basic and phosphorus. But there's a lot of situations where you can use it. Another thing of note is that POST, even though there's maybe some similarities between this media treatment method and the HPBSM, is that the HPBSM from the previous slide was developed and approved to be an in-ground facility like you see here, conventionally kind of sloped on the sides and in-ground, whereas POST was specifically developed in a box. So it's important to keep that in mind when you're selecting one or the other. POST continued. So here you can see you still have that 18-inch primary filter media layer. You have ponding on top, and then we're showing that secondary polishing layer. Another option that a lot of people are familiar with now is, well, there's a variety of proprietary medias, but what I'm familiar with is Context Filtera system. Very, very high infiltration rate. It's, as a hydraulic geek, it's kind of hilarious how much water you can force through these facilities. But like I said, it's proprietary. There's tons of orientations. You have vaults that you can put under sidewalks. You kind of see this example has plants on top. A lot of times people stick a tree in there, or you can just keep it like a hard top and you won't even see it. There's also a variety of different like in-ground options, or it's flush with the ground. And one of the sites that we'd be visiting on Wednesday is this, we call it the UW Regional Bioretention Facility. It's in fact a Filtera system. What's cool about this one is that it's really integrated well into the Prairie Line Trail. I know a couple years ago when I was walking through that, I had no idea it was a stormwater treatment facility. I thought it was just kind of a cool, I don't know, a rain garden or just kind of landscaping. They've got the old rail line kind of integrated in there and kind of nodding to the Prairie Line Trail, which is a railroad that used to go down this road. It's nicely landscaped and blends in pretty well. And I think in terms of a use case for Filtera, I think this is a great example where they had room. It's a part of campus that's already pretty well maintained, so there's a low risk of it getting vandalized or getting a ton of garbage dumped into there. And this facility is actually part of Tacoma's fee and lieu stormwater program. So for those who aren't familiar, our fee and lieu is basically a program where developers can opt to buy into an existing facility instead of doing their stormwater treatment requirements on site. So this facility is treating about 45 acres of the FOSS and is physically on UW property. So it's a nice situation where we get a fee and lieu facility. It's not taking up right away, and there's a lot of benefit for the developers in the area. Moving on to kind of our last variation of it, structural soil cells or Silva cells and stratovaults. A thing to note here, and I'll get to some cooler pictures here, is that the Silva cell or stratovault isn't a treatment BMP by itself. What you're buying is basically a structural cell for a bioretention media to exist inside of it. So the main goal here is that you're able to put pavements, roadways. I think both Silva and Stratovault are HS20. It's either H or HS20 rated. So it's has the structural capacity for you to be able to park a truck on top of it and not have any issues. So again, comparing typical bioretention to the Silva cell, we have that 18-inch treatment media, we have a ponding layer on top, and then an underdrain underneath. And really the great opportunity here is that when you're looking at, okay, what can your stormwater treatment system do more than just treating stormwater, or what can it add to other projects, is it's a great opportunity to add trees. So if you're in a really dense urban corridor where you're really competing for space and you need those tree canopy benefits, this is a great solution. So another one of the sites that we'll be visiting that's nearby the UW Bioretention are these trees. So these trees are planted in those Silva cells. So the Silva cells are buried underneath the asphalt or the asphalt and the concrete. You can't even see them. Yeah, that's it. These were built in, I think, 2012. So what is that, 13 years later? These are some pretty large, healthy trees. Really haven't had any maintenance since 2012. Like I said, this is bioretention equivalent. Some other benefits is that the trees have soil volume that is appropriate for them. They're able to get enough water, get enough nutrients, and then they're also not sending roots into or underneath the adjacent pavements and heating them and causing other kinds of damage. What's also cool here is that there's very little space needed. So instead of having to have an 8 or 10 foot planter strip, a conventional planter strip, we can still have these narrow 4-foot planter strips and get large trees in there. I've snuck in some photos of construction when the user, I guess it was built in 2013. I lied. But another benefit of these Silva cells is kind of the adaptability. So we have a utility vault here, and the cells are being placed around the utility vault. I think there's like a geogrid that's separating the bioretention media from native soils, and you can see a utility conduit that's kind of being snaked in behind the Silva cells. And you see the hat on top. And then this next slide, we're showing some things that we're trying to avoid. So on the left, this is also on Pack Ave, maybe another block down. This is a tree that was, I don't know, I think it was maybe late 90s, early 2000s it was planted. That is a big problem that we see with trees planted in downtown corridors with a lot of hard surface, is that if that tree is healthy enough, it will survive. It's just going to destroy everything around it. So we've got heating panels, the little decorative cast iron here is getting pushed around. And I think if you're to measure from the top of the curb to how far that concrete panel's been pushed up, I think it's about 6 or 7 inches that it's been lifted up. Another great thing with Silva cells, as compared to like a Filterra box, I mentioned like one of the orientations of the Filterra boxes, it's pretty common, is you get the vault and you stick a tree in it, and then you satisfy your street tree requirements. And unfortunately, what we're seeing with pretty much all of our facilities where it's a tree in a Filterra box is that like on the right here, this is kind of the outcome. This box was built also in 2012. So compared to the trees we saw originally that I took just this last summer, I mean, these are, well, probably 30 foot tall plus trees versus this sad little tree that's dying and withering away. That's one of those kind of site specific considerations you want to make. Like, okay, are you checking a box that you planted a street tree, or do you just genuinely want a healthy tree that's going to live and survive? Kind of another interesting facet. I had to steal this from Google Maps because I cannot time travel, but this is the Marriott also on Pac Ave. You can kind of see they have these trees in these giant planter boxes. I think that was pretty typical for that section of Pacific Avenue for quite some time. But I mean, those planter boxes are not very big. It's maybe, I don't know, 6 foot by 6 foot and a couple feet tall. So it's a lot of maintenance. You have to water them a lot, but obviously trees are really important to this corridor. And so what I kind of like to show off is going from this photo where it looks kind of nice to these photos where it's in front of the same block, but now 15 years later, we have these like pretty massive trees that are able to have that same benefit as those planters did before, but with the benefit of stormwater treatment. You know, we're having these property owners in the city aren't having to spend money on irrigating those little planter boxes. So I think overall it was really great success and use case for Silva Cells. Now, Eric and Kevin, I think a couple weeks ago, you folks had done some investigation on these facilities because we hadn't looked into them very much. Could you tell us a little bit about maybe what you saw and how these are performing?
Yeah, we recognize there's pieces of the Silva Cell system that we can't observe from the ports that allow you to look into the distribution pipe where the water flows in from the catch basin on the street or the under drain. So we had a push camera push through both pipes to get a sense of sediment loading on the distribution pipe and get a sense of the health of the under drain. The under drain looked great. The distribution pipe was collecting and building up floaties. So your pine needles, your leaves, your wrappers, typical debris that's going to be buoyant and float. So working with Scott to think about some kind of pre-treatment or things we can do upstream to trap those things in a catch basin or prevent them from getting into that distribution pipe. So really glad we took the time to look at it closer and get a sense for its overall health. It is still perking. It's not causing any flooding. It's functioning as designed. But your distribution pipe is going to be where most your maintenance is going to be.
And when Kevin's talking about the distribution pipe, it's this pipe that's kind of replacing the ponding. So in the case of Pac Ave, we have a CV that's in the traditional gutter line, and then it just has a lateral stub into this distribution pipe. Now, Kevin, I am understanding that we've basically done no maintenance on these facilities other than just the poking around we just did.
Yeah, the catch basins, they have been getting cleaned as needed to do the best they can, capturing the sinking type sediment and material that goes into the catch basin. So now moving forward, it's developing some sort of tool to help us remove that the floaties that get stuck in the distribution pipe.
Gotcha. Okay. And then are we going to be able to maybe take a look at that observation port on Wednesday?
Yeah,
Or
Eric and
see
I
what it looks like?
we found two ports right next to each other. One's the lower drain, and then the other one's the distribution pipe. And we'll be able to see the material we're talking about in both, and be able to see the clean pipe below.
Awesome. And we'll have some more time to talk about it too.
Yeah.
All right. Thank you. So kind of running out of time here, but some key takeaways that I'm hoping you all got was the importance of being flexible and kind of adapting your designs, not just in the heat of the moment, but consciously looking at how your planning processes and how you develop projects while you're designing them, how you can be more adaptive and flexible. And then also after it's built, there's always room for room and opportunities to kind of succeed and grow, or maybe retroactively make some changes to a project to make it work better. And of course, I take being a public servant really seriously. Like, I want to address the community, and I want my solutions that I come up with them to be representative of their perceived, their real issues we're trying to solve. So I think it's always important to keep that in the back of our heads when we're doing these projects that we're serving them. So I apologize, we don't have very much time, but we have questions that we can get to, and if we can't get to them, I know that Shauna and I will definitely be willing to reach out to folks and start some email chains if we need to answer these questions.
We do have one question from Bill in the chat about the new bioretention media that you were pointing out. I think maybe the post media, that's kind of that specialty media. And if it's like, can it be acquired in large amounts for projects yet, or is it pretty much a hand mix kind of thing?
That is a very good question. I do know that there was a specific landscaping company that worked with Herrera while they were developing this. So it's a little bit custom at the time. If you look up guides on Ecology's website, or if you can find Bellingham's post their design guides, they have specifications, exact specifications for the types of materials and the blend quantities. So push comes to shove, hopefully you have a contractor to be able to custom mix that themselves, or they have access to a landscaping company that would be able to do that. So it's not, I wouldn't say commercially available, it is out there. The most difficult ingredient that I've heard of is the activated alumina. There's some concerns about sourcing that, and the main concern with sourcing it was the quote unquote greenhouse impact on having to ship a material from maybe not the West Coast to get it. But that's a small portion of that post medium, so I'm sure it can be sourced in appropriate quantities. And I can find out who that landscaping company was and maybe distribute that if it helps.